take a look at number 46 through 50. But before we do that, let's take a look at number 40 as we missed out getting to work on that one in the previous video. Okay, so they give us a scaling triangle, they give us an angle here, two sides, and they want us to find the side opposite it. Thankfully, this one is quite straightforward. This is a law of cosines. So this side opposite here, C, we can solve it with this formula right here, which is looks a lot like the Pythagorean theorem, but it's got this correction term over here for the obtuseness or acuteness of a triangle. Anyways, so c squared equals a squared plus b squared minus 2ab cosine of the angle creating C. That's the important thing. Doesn't really matter who's A, B, or C per se. The most important thing is the consistency between the angle and the side that you're solving for. They have to be opposites of each other. So in this case, C has to be the side opposite of the angle given, 0.826. Now whether A is the 3740 or the 4260 doesn't really matter. But please keep in mind that relation between the side you're solving for in law of cosines and the angle provided. When you use your solver, sometimes they might even give you C and the angle opposite it, and you might have to solve for B or A. That's okay. Just put C and the angle where they belong and leave your variable for B or A, respectively. Okay, let's go ahead and take a look at 46. Lasagna, one of my favorite things to eat. Well, this recipe makes for 12 servings. That means that, assuming everyone is humble, we each get a serving. So 12 people will eat for half a cup of chopped onion. Be mindful of this terminology because they ask how many medium onions are needed to feed 150 people. If the servings are 80% smaller than the regular recipe, oh, and by the way, a medium onion yields 1.2 cups of chopped onion. So the idea here is that we're going to be building up a solution by feeding 150 people, but first we will need to find out how much chopped onion we're going to need. After we find out how much chopped onion we're going to need, then we're going to convert that into the amount of medium onions. So let's go ahead and try to build some equations for this. Okay. Well, first thing we'll do is we're going to say that we have 12 servings for half of a cup, and we're trying to make 150 servings. So we'll do a straight proportion here. Now, if you're wondering, well, do we square, cube, servings, or cups? The idea is as we eat, we take a mouthful, which is a volume. So, and that volume is what we consider a serving. Well, until we've eaten and been fed, right? But that serving is a volume quantity. And cups themselves are also a volume quantity. So there doesn't need to be any kind of proportionality exponent tricks with the quantities they give us. Okay, it's going to be a nice linear or straightforward direct proportion. So 150 over 12 is going to equal 0.5 cup, or x over 0.5 cup of chopped onions. Solving for this, we get 24 cups of chopped onions. Now, the servings here are going to be 20% smaller. That means that the servings are 80% as big as before. So we only need 80% of this much chopped onion. So we take 80% of the 24 and we end up with 19.2 cups of chopped onions. Now, one medium onion is going to create 1.2 cups. So if we divide by 1.2 cups, that tells us how many medium onions we need. And so that's going to be 16 cups right there. Let's continue with the next one. 47, regression. A 100-watt light bulb puts out 1,500 lumens of luminous flux. Excuse me, I'm going to take a sip of my coffee. Thank you. Luminous flux is inversely proportional to the square of the distance from the source. Michael measures the luminous flux as a function of distance. At 2 inches, it's 365 lumen. At 5 inches, 57 lumen. At 8 inches, so on and so forth. And they want us to estimate the distance at which the luminous flux drops to 1 lumen. So when we're doing our linear regression question or setup here, the y values are going to be the lumens. So 365, enter. Now the distance here, so that we can get a direct linear proportion, we have to manipulate the distance variable. And they tell us that it's inversely proportional. So what we do with the 2 inches, the 5 inches, 8, and 11, is we're going to need to take the inverse and square it. Or we're going to need to square it and take the inverse. The order doesn't matter here. Whichever one you feel better typing in faster would be the approach. So for the first entry, 365, enter. Then 2, push the square button. Do not push enter. The square button is a 1-number function. You just need to push that and it'll square it directly and put the result right where it needs to be. Then the 1/x button. Once you've gotten that, you should have 1/4, so 0.25 in the x register. And then you do the sigma plus. And then you continue with the next term. 57, enter, 5 square, inverse, sigma plus. Then the next term. 25.7, enter, 8, inverse, square, sigma plus. Decided to say it in opposite order this time, just for whatever's sake. So on and so forth. Then you do 1 linear regression. And because this is the y value, you're going to predict the x value. Now the x value it gives you is going to be the inverse squared version of the distance. So don't just write down that number. You have to undo the inverse and the squaring. So how do you undo an inverse? You inverse it again. So when you get the number from the calculator, inverse. To undo the square, you square root, and there you go. 48. It's a solver. Throw it into the solver. I'm going to assume that is 3 times the square root of 7 times g minus 5 equals e to the g. If you want to give your calculator bounds on the solver, on the Inspire, you put it outside the solver. So you do the little vertical bar such that g, or x, is greater than 1. For the prime, you can put comma x equals 1, and it'll get you there. 19. 19 is a nasty question. At least it looks intimidating. They don't give us the side length of the cube, and all they tell us is that is the cube. They want us to find the angle between the rays traced out, or the segments traced out by a line going from the corner to the center of a face, and a line going from the corner to the midpoint of the vertex opposite the cube. All right. Well, the important thing here is to realize that there is no 3D-ness. In reality, this is a 2D triangle. So we're going to go ahead and solve this using law of cosines. So in law of cosines, they want us to find this angle. So CM, that segment over here, is going to be the opposite side of the angle. So this segment here squared is going to equal this segment squared plus that segment squared minus 2 times this segment squared times that segment squared times cosine of the angle. And you're going to throw that into your solver. The challenge is, how do you write these segments? Well, you have to use the super Pythagorean theorem, the 3D dimension version of this. X squared plus y squared plus z squared. And so let's go ahead and take a look over here. So for line segment OM, OM is going to be going this distance right here. So this x distance is just the side length of the cube, x. Then y squared is going to be this distance right here squared, which is another side length of the cube, so x again, plus halfway up this line segment. So this is the third dimension. This is z. So x squared plus y squared plus z squared would give us OM squared. And in this case, z squared is going to be half the side length of the cube, so x over 2 squared, quantity squared. X squared plus x over 2 squared, that's 2x squared plus x over 4 squared. Don't forget to square the 2 here, common mistake. Throwing all that into the calculator, that's 8 over 4 squared, x squared, plus x over 4 squared, that's 9 over 4 squared, x squared, square rooted, and so we get 3 over 2x. So that line segment from the corner to the midpoint is 3/2 of the total side length of the square, if you were to calculate it. For segment OC, which is from the corner to the face center, we're going to go a distance of, and that's this blue series of segments, x over 2 quantity squared. We're going to the center of the face, so we're also going to go x over 2 in this direction, quantity squared, so x squared, y squared. And then z squared, we're going to go all the way to the top, so we're taking it all the way to the top, x squared. So for OC, x squared, x over 2 squared plus x over 2 squared plus x squared, can resolve all that. That's a fourth plus a fourth makes a half plus a whole, that's 3 halves. Square root of all that becomes square root of 3 halves times x. And the last segment, CM. It's half the distances in each of the directions because it's from the midpoints. So boom, 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 boom. And the last thing you do is you just throw that all into your solver with the law of cosines to solve for the angle. I would personally leave this question to the very end unless you happen to have the law of cosines defined into your functions, as well as, I guess what I keep calling it the super Pythagorean theorem, but it's to find the distance in 3 dimensions, and it's just those 3 perpendicular dimensions squared added up. I would personally recommend you guys have those defined so that you pass through the variables in the functions and solve it right away. Then I would tackle this right away, but leave that one to the end. All right, 50. They give us a cone and a hemisphere, and they say the total cone surface area. Be very careful here because the shape here does not reference the full statement. All right. But they tell us that the total surface area of this cone is going to equal the total surface area of a hemisphere. So for the cone, it's going to be this lateral surface area, the shape of the cone, the area of the waffle, if you will, plus the area of the circular base. So that's the total area of the cone. Now in this case, the figure doesn't have that base, if you will, because it's like 2 solid shapes put together, but that's the setup for the math. Now to get the lateral surface area, that's pi times r times this side length L, the slant height. And the slant height is going to be determined from the Pythagorean theorem. Now, putting all this information together, they want us to find the height of the total assembly. Now, they give us the radius of the hemispherical cap. So if we take away that radius, that's going to give us the height of the cone. So in this case, we're actually looking for that total height, x, and we're going to take away the 5.55 to get the height of the cone. So from there, you do the Pythagorean theorem with 5.55 for the base of our triangle, because of symmetry. It is from the edge of the circle to the center sphere. And then with the height of x minus 5.55. You do that for the Pythagorean theorem to get your slant height, and then you're going to plug that in over here. So your solver is going to be solve the area of the cone, pi rl, plus pi r squared. And the same thing is going to, or that same little catch is going to apply for the hemisphere. The total surface area of a hemisphere is going to be 3 pi r squared, because it's half the outer surface area of the sphere, which is normally 4 pi r squared. Cut that in half, 2 pi r squared, plus that circular area at the base, so 3 pi r squared. Throw that into your solver, and then you've got it.